morning, everyone. My name is Jakub. I'll be presenting a slightly different approach to parsing or using XSLT with large documents and with multi-threading. And I like to actually start with something a little different, which is streaming. We've had 2 talks last year about this, and streaming is now part of XSLT 3, and for me it's like a whole new area of application, because we can now process documents that are huge, and this was not possible before because we were constrained by the size of memory. So this is like a whole new area where we can now apply XSLT. But there are some limitations that come with streamings. There are trade-offs. You have to follow some rules when you're writing streamable style sheets. Again, there was a very, very nice summary of the rules last year. They can get complex, but if you follow some simpler recommendations, you should be fine, but those limitations are there. So the specification went this way. We will give new possibilities to use the language, but you can't use the whole language. You have to use a subset to be allowed to use streaming and process large documents. And with large documents, there is another issue, and that is it takes a long time to process them. So this is an example we've actually seen last year as well. It's a document that you can download on the internet. There is a link in the paper. It contains a database of proteins. It's 700 megabytes in size. And if you write a streamable template, you can process this document. If you don't, you will probably run out of your memory on your machine. So you have to use streaming. But if you write even a very, very simple style sheet, it will take quite a long time to process the document. Yeah, it's about 35 seconds for the example style sheet I've used for these measurements, which just picks some data from the documents and throws away everything else. So it just looks for specific elements and puts them in the output. So nothing complex. Yet it takes 35 seconds, and there can be larger documents than 700 megabytes, and there can be more complex style sheets. So this is like a new bottleneck for the user. And you've seen, well, how does this document look like? It's basically a large collection of records, those protein entries. Here, they basically are self-contained records about one protein. I'm sure those letters mean something to someone. And there is not real relation, just one big collection of records. And in the previous talk, Michael K. mentioned that, for example, when you're using collection function, it can be multi-threaded. But in this case, the problem is the collection is in one file. And if we want to multi-thread one file using for each, we would have to load it into memory first. So that's not an option there. And another important thing is that the transformation time can be actually dominated by parsing time, and it is in this case. So the parsing of the documents, it's what takes so long. And if we, well, what we want to do is make this run faster. And one way to do that is to process the records in parallel, but we have to follow some limitations again. So if we want to run this in parallel and overcome this limitation by, or this speed limitation from the parser, we have to run several parsers at once on the same document, which means they will be independent, and an instance of a processor connected to each of those instances of the parser, and they don't know about each other, so they can't refer to data that they haven't seen because this data is processed by the other parser. And this is very similar with streaming. With streaming, you can't go back, you can't go forward. Well, you can, but you have to do it like in small steps, basically. In streaming, you can go up because the processor caches the whole path to the root of the document. So if you're processing one protein entry, you also have all of this available. Here, it's a little bit more difficult because when you're start parsing somewhere here in the middle of the document between the two protein entries, so this part this processor haven't seen everything that was before, and that's why it hasn't seen the route to the path, the path to the root. So that's an additional constraint. You can't go up from basically the record. You can go, or you can process the record. If you're somewhere down in the subtree of the record, you can go up to this level, but not above. So yeah, Michael has already given the introduction on why we want to use multiple processors and why it's a good idea, because everyone already has them. And we want to run parser and a processor in multiple threads, even when we are parsing one document, and even if it's one large document that we are processing in a streamable template. So here are some results, and you can see, well, again, what's been going on. I've ran several parsers on the same document, several instances of Saxon EE with streaming. If you run the transformation without like with normal Saxon, you finish in 35 seconds. If you run it with my program that is a simple wrapper around Saxon, and you run it with one thread, there is some overhead. But if you add more threads, you get improvement. So this was run on this laptop, which has 2 cores, each with 2 logical cores. So there was not really any point on adding more threads than 4. This gave the best results. It's about 30% decrease in runtime. But there's every reason to believe that if we ran this on another machine which has even more cores or more CPUs, it would run even faster. So we have trade-offs. The most important one I've already mentioned is that we can't go out of the single record that we are processing if we are using this approach. In the previous talk, Michael mentioned that there are also trade-offs in the implementations in Saxon, and basically the main problem is the problem of side effects, like the simple ones like XSL message, or the more complex one like user writing his own functions, which have side effects and the processor has no idea what they do. I will talk about those side effects a bit more later. Because we're using large documents, we use streaming, so every limitation imposed by streaming applies here as well. So you have to write streamable templates, and you can't go out of the record. So it's obvious that it's not really applicable for any document. It has to be a special type of document that you can process this way. It has to be a document that has a well-defined structure that you know in advance, and it has to consist of reasonably independent records. So where you're processing one, you don't have to know anything about the other ones. The name I use for this is a core type, which is the protein entry in the example. So it's a type that basically the whole document is a collection of instances of these types. And another requirement on the input is that we have to be able to read it from multiple threads and from random positions. Because what the program does, it actually looks somewhere in the middle document, tries to find a place where a record starts, and starts processing from there. There are also requirements on the Strongsheet. It has to be streamable. We have to mark explicitly the core templates, or the templates that process the core types. And those templates that use this PXSL core attributes have to have simple matching patterns. I've used only child axes and element names. You probably could get away with something a little bit more complex, but you can't do, for example, predicates somewhere above the core type. So if there was some predicate here, the processor couldn't evaluate it properly because it hasn't seen the actual part of the document that this predicate should test. And so why is there this limitation? Because when the processor starts somewhere in the middle of the document, it has to know where it is. Basically, it has to know the path to the root. So if it sees a protein entry from this match pattern, it knows that there is a protein database element above it. So an alternative would be to provide a schema for this, and this could lift some of the limitations on the match pattern. There are some special cases which maybe are not that special really. So maybe focusing on them would bring some benefits by decrease or by lifting some of those limitations. For example, if a document looks like this, so there is some small part in the beginning, and there is the big part, which is the most of the document really, with those individual records. We could read this intro in one part and then pass the information about these documents to all the other instances of Saxon, and when we are processing these in parallel, we could refer to the data that were in the interaction. That's one thing that could be done. But basically, we have to know that all the core nodes are the children of the same node. If we can't, if we can't rely on that, so the core nodes have some layers above them, and some of them are children of one element and other are children of another element. We can't do that, what I've described before, but maybe we have just chosen the core nodes wrongly. Maybe we should have chosen this layer as a layer for core nodes, and we can do exactly the same thing. So problems we can see when parsing somewhere from the middle of the documents. Well, we have to find a place where we can start safely somewhere at the beginning of the record. But if we have the bad luck and we find a place that, for example, is in the middle of the comment, and the processor hasn't seen this, that this is a comment or a processing instruction or a CDATA section, it will fail or throw an error if we don't account for this. Well, what we can do is, what we can't do is parse the document with an XML parser and look for the comments in advance, because that's the thing that's slow. This is the thing that we want to avoid. And so we have to find another way to look for these problems, maybe some other pre-processing, not XML-based, because all of these are actually comments, PIs, CDATA sections. They are linear. They are basically marking a part of the document, and if you look at the XML as a string, those are substring in that, so just some simple text-based pre-processing and locating those sections and just telling the processor later, please don't start parsing in the middle of these places could solve this. Or we could try to come up with some fast XML parser, but I'm not sure whether it's possible. We could we could skip some pieces of XML like attributes and resolving namespaces and stuff like that. And maybe it would produce a parser that is fast enough not to dominate the time needed to transform document. But I haven't researched this, so big question mark there. So those are the problems with the parsing itself, and there are the side effects problem. Some of them were mentioned in the previous talk. Users sometimes write stylesheets that are not purely functional. They can use XSL message, and if we run multiple threads and they all print XSL message, it would interleave. There can be, for example, mutable variables that processors provide for as vendor-specific extensions, and users can write their own extensions and call functions with side effects. So this probably has no real solution. So if a user decides to do this, he hates to take he has to take some measures to prevent race conditions in his code. So the experimental implementation I've used to test this was a simple wrapper around Saxon EE. It's available on GitHub, but it's very simple because I had to do a wrapper because there are no open source streaming processors. So it's a little bit hacky. And what this does is that actually it splits the documents into portions of roughly the same size, and then create a separate instance of Saxon and run this instance on each. Run a separate instance on each portion of the document, and when all they are done, the results are matched into the output. The code is available on GitHub, but it's a lot of stuff is hard coded there, so it's not something that you can download and use to make your style sheets run faster. It's something that you can take a look and replicate those experiments and verify that I'm not making this up, because this really makes little sense to implement outside of the processor. If there is application for it, it needs to be implemented inside of the processor. Another use case I've tried is something that comes from real life. We did this a couple of years ago. Basically, had to parse a large XML document containing data about the cities, streets, buildings, and load the data into our enterprise system. And the problems with those files is they are usually small, but because they are created city by city, the one for Prague is quite large. It's 600 megabytes of data. And we needed to split those records about every street and house and building into a single file. And this, I tried writing this now after well, this was many years ago I did this, but I tried this now using streaming and Saxon EE. And even though the template is quite simple, you can find it in the paper, it takes actually 42 minutes to run this in Saxon. But when I ran it on 4 threads, I got a significant improvement in speed. And so 15 minutes is still quite a long time, but it's a very significant decrease. So to conclude, processing in multiple threads gives measurable speed up. It's 1/4 of the time in the previous example. But it imposes additional limitations on the style sheet and on the input. It makes sense to use it only for a very specific class of documents. And this particular approach makes sense only for large documents that don't fit in memory. And you have to use streaming, because if you have a document that you can fit into memory, you can use the optimizations that are already available in Saxon, and Michael K. was mentioning them, like using Saxon threads with for each or apply templates instructions. And that's all from me. And if you have any questions.
Thank you very much. So we have time for questions before the break. Michael? Anyone else?
It seems to me that what you've at least prototyped is a scheme where you're doing a rough parse of the document sequentially, finding the start tags and end tags of interest, and then you're passing off parts of the document to another parser to do a more detailed parsing. And I'm wondering so the essence of this, in a sense, is parallel parsing rather than parallel transformation. And I'm just wondering if that approach to parallel parsing is something that can be industrialized to the extent that we're really doing all the proper well-formedness checking by doing the parsing in those two stages.
Maybe. Yes, probably. Well, if the style sheet runtime is really significantly dominated by the parsing time, then just having a parser that runs in parallel will bring very similar results. But if there is actually some benefit coming from the actual style sheet running in parallel, maybe having multiple threads for the actual processor gives another additional benefit. But what I did actually is not a rough parsing of the documents. I just divided the size of the documents by the number of threads and start parsing somewhere in the middle. Shift it a bit if I didn't happen to hit really the start of the record. So, as I've said, it's very, very simple.
Okay, thanks.
Thank you. Alex?
This is a very interesting work. I did something like this 15 years ago, which for me led to the viewport stuff that's in XPROC. And I was actually doing bio data, same stuff, similar stuff. So that's really, really interesting to see a modern take on that. But have you considered how a user might specify this? For example, XPROC viewports, XPath, streaming XPaths, and sort of how would you constrain that so that you could, to the things that are actually tractable, given, for your example, right, of certain subtrees that repeat over and over again. And because I didn't see how you actually told the processor what the subtrees are. Is that just code, or is that like an XPath, and how can we turn that into its declarative specification?
Yeah, I maybe was too fast with that. I've added an attribute to a template, and this would tell the processor that this template processes the record, so it would be match protein entry, then there will be PSSL core, which is the core node. And that's the way the user has to come in and say, this is the important type in my schema that actually makes largest part of the document, and this is the type I want to process in parallel. And for all the other checks, I don't do them. So I just hope that the user will not, for example, try to read up from the record. That's again something the analysis of the template would need to be done in the processor.
Okay, Eric?
Yes, you've mentioned troubles with comments, but don't you have troubles with namespace declarations also? I think because here you are using the default namespace. I assume that if you were redefining, you would be.
That's a very good remark. Yeah, I haven't accounted for it. The user would have to be very careful with namespaces, like declaring them at the top, for example. That's a very good point.
Any other questions? So thank you, Jakub. Thank you very much for this talk.